Unsized array initializations. Imagine that you are using an array initialization to build a table of error messages as displayed here. As you might guess, it is tedious to count the characters in each message manually to determine the correct array dimension. Fortunately, you can let the compiler automatically calculate the dimensions of the array. If, in an array initialization statement, the size of the array is not specified, the compiler automatically creates an array big enough to hold all the initializers present. This is called an unsized array. Using this approach, the message table becomes like this. Given these initializations, this is the printf statement. The above statement will also print like this. Besides being less tedious, unsized array initializations allow you to change any of the messages without fear of using incorrect array dimensions. Unsized array initializations are not restricted to one-dimensional arrays. For multi-dimensional arrays, you must specify all but the leftmost dimension. The other dimensions are needed to allow the compiler to index the array properly. In this way, you can build tables of varying lengths, and the compiler automatically allocates enough storage for them. For example, the declaration of tables array as an unsized array is shown here. The advantage of this declaration over the sized version is that you may lengthen or shorten the table without changing the array dimensions. Reading array elements. Once you've initialized an array, it's easy to retrieve the elements. As we discussed earlier, to retrieve and to assign an element, we have to use the index. Let's take a look at a sample program, which shows reading elements of an array. In this sample program, we declared an array called x, which can hold 4 integers. Following the declaration, we assign the integers sequentially. Then we print an element which is located in the first location of the array, so the output will be 23. Now run this program to verify the results. Here you can see the output displays 23. Close the output window by clicking the Close button. In the previous sample, we discussed how to initialize an array and how to retrieve an element from the array. But this method is not helpful when the array has many elements. In that case, we may use a for loop. Here's a sample code. In this example, we declared an integer array variable called ARR, which holds 10 integers, and another variable named I. Then we print a text message using the printf function. Here we generate a for loop to repeat 10 times. Each time, this scanf function will ask for an input and assign it to ARR of corresponding index. When the input is done, we print a text message. After that, the control will come to the for loop. Here we print the array elements. To view the output, compile the code using Alt F9. When it is finished, click OK, and run the code using Control F9. Type 10 integers one by one. When you're done, you can see the elements. If you want to learn more about arrays, try these tasks. From the given example program which we discussed in this lesson, print the array elements in reverse order. Declare an array with 5 elements and input them. Then display the elements by adding 2.